Okay, we are going to practice drawing a few of these particular solutions given a slope field, and then we'll also show how to draw a slope field. Okay, so if we are given some initial conditions, like the point -7, 2, so if we find ourselves at -7, 2 right here, and we just go with the flow. I love this so much. I'm going to flow, so I'm going to kind of come down here. And then I see that it goes swooping up, something like that. And it doesn't matter that I don't have the equation for that created the slope field. Totally doesn't matter. It's just getting used to drawing some particular solution. So here's my particular solution. You know, by the time you got over towards the right edge of this, you might be at a slightly different spot. You probably will be, and that's okay. It's not exactly it's not an exact science. It's Zen. I love it though. Okay. So looking at, say, -5, -1 here, and I follow my Zen, I go with the flow. I feel like I should be going like Om, or, you know, but I don't meditate. It makes me crazy. I know it's supposed to not make you crazy, but whatever. So if I just kind of go with the flow, that's what I ended up with. And notice I didn't cross over. And you would never end up crossing over, because if you had like a crossover spot, that would mean that like you'd have like a decision to make once you hit that point. Say these two crossed over at the point -1, 3, and then it'd be like, well, which path do I follow from here? So these, you know, any x comma y is gonna have a totally different set of points, at least as far as I know. I can't think of an example of it happening otherwise. I don't see why it would happen otherwise. I really don't. Okay, finally, if we look at 8, -4 down here, so if we go with the flow and we just follow this guy around, and it's kind of maybe doing something like that. So cool. I love this stuff. Okay. So drawing a slope field, so we're going to draw the slope field for x over y. So one thing we can do is take advantage of patterns. Math is patterns, right? Another thing we can do is use a ruler. Sometimes that's helpful. Kind of helps me to visualize things occasionally, to use a ruler. And I have a really fancy one. It's metal and it's so nice. Okay. So if we have x divided by a y, looking at some patterns, I'm like, well, if x is 0 and y is not 0, my slope is going to be 0. So that tells me that anywhere on the x-axis, sorry, on the y-axis, left, right is 0, but when not the origin itself, my slope is 0. So I'm going to put some horizontal lines. Okay, if y is 0 and x is not 0, so anywhere on the x-axis, we're going to have vertical slopes like what we saw on our first video with the ellipse. Those slopes were 0 as you approach the x-axis. Okay, and then if x and y are equal to each other, my slope is 1. So anywhere here, except for the origin, my slope is 1. So this is when I can, if I want to, throw a ruler down, and I'm just drawing these little dashes at all my grid points. And then obviously if x and y are equal to each other but opposite signs, i.e. the second and fourth quadrants, here we have that diagonal happening. So here's actually a really nice explanation, or a nice illustration of why 0 divided by 0 is called an indeterminate form. If you recall, that phrase indeterminate means you cannot determine it. Because basically, like, I just followed 4 different patterns. My first pattern was on the y-axis and I had those 0 slopes. My second pattern was on the x-axis when I had those vertical slopes. And then I had my 1 slopes and my -1 slopes. Okay, so knowing that math is patterns, if we're at 0, 0, which of those 4 patterns should I follow? It doesn't work, does it? You can't follow multiple patterns at once. So that's a really nice little example of why 0 over 0 is one of those indeterminate forms. Okay, And so now we can just fill in those remaining points, and we'll use symmetries and such to kind of help ourselves along. So looking at the point 2, 1, so if x is 2 and y is 1, 2 over 1, that's a slope of 2, so it's here-ish. 3, 1, that's a little too steep actually. And this is when that ruler kind of can come in handy, because like if I can throw my ruler down and go, okay, that's a slope of 2, I can then draw a decent line of it, because I tend to go towards like a little too steep or not steep enough. But to be honest, it's not that big a deal. Okay, so if x is 3 and y is 1, it's just a little steeper yet. It doesn't have to be exact. Even if this were on the AP test and they made this a test question, they would just be like, are the zero slopes in the right spot? Are the vertical slopes in the right spots? Are things positive where they're supposed to be positive and negative where they're supposed to be negative? Okay, good enough. You know, like, is it relatively good-ish? Okay, at 3, 2, my slope is going to be 3 over 2 or 1.5, so that's between those, or it's not quite as steep as 2, so again, it's not an exact thing. And then, so at 2, negative 1, I'm going to have a negative 2 slope. And so notice that I have this vertical reflection, and I can just kind of steal those. So I can just use symmetries. Okay, if x is 1 and y is 2, then my slope is 1 over 2, so a half. And then I can reflect. And then I can also reflect this side, and I can reflect here as well. And then if x is negative 2 and y is 1, I have a negative 2 slope. So close enough, and then I can reflect that. So we can just kind of use reflections a lot. It's pretty handy that way. And it doesn't have to be totally, perfectly, incredibly awesome. It's just close enough. And then once we've done that, we could, you know, draw in some particular solutions. I'm going to skip that part, because with so little of the of the slope field drawn, it's actually kind of hard to do that. It's nicer to have, you know, a big old set of points to follow. So that's how to draw a slope field.